Hi, thank you so much for joining me. In this video segment, I want to look at an introductory level prediction of double replacement reactions. Now, for a double replacement reaction to occur, there needs to be a driving force. And the common driving forces are the formation of a solid that we call a precipitate, the formation of a gas. You would see that if a double replacement was followed by a decomposition. And then we would also include the formation of a molecular substance such as water. That's what we would see in an acid-base neutralization, for example. Okay, so in this case, we have solutions of potassium nitrite, and it's reacted with a solution of tin 2 fluoride, aqueous solutions. Okay. And potassium is plus. It can help you. You need to erase it afterwards, but I think it can be a big help if you write the charges underneath. So you'll see very clearly that the positive potassium is got to go with the negative fluoride. And since I have +1, -1, I'm going to have potassium fluoride. All group 1 salts are soluble without exception. And that leaves tin +2 to go with nitrite. So it'd be tin 2 nitrite. And if you know your solubility rules or look them up, you would see that's a solid. And then I would need to balance it. All right, double replacement, if you, again, let me follow through. AP is very, very picky about this, as is IB. You want to be careful that you're not implying that these formulas are ions. So if you're writing a formula, a neutral formula, you don't want the ion to show up inside. So do this and then erase it if you need to. But I want to do this to make a point. You notice that nothing changed, oxidation or reduction numbers here. There were no electrons exchanged. So double replacements are not redox reactions. And in this case, we formed a solid. So this would be considered a precipitation reaction. Okay, aluminum sulfate, and it says it's a solution of, so it's aqueous, plus calcium bromide. Okay, so we've got +3, -2, +2, -1. So the +3 aluminum doesn't go with the +2. That's why I think it's really helpful to get those charges down, even if you have to erase them. +3 goes with the -1. So I'm going to have aluminum bromide, which is soluble, and calcium sulfate, which if you look at your solubility rules is not soluble. And then we would need to do a quick balancing. Again, double replacements are not redox reactions. A solid precipitate formed when 2 aqueous solutions were added together. So that would be considered a precipitation reaction. Okay, hydrochloric acid, HCl, is reacted with calcium hydroxide. Okay, put those charges underneath. And you see that the +1 hydrogen wants to go with the -1 OH, which that's water. HOH is water. So I'm making water, and that leaves calcium with the chloride, and it is soluble. Wouldn't have had to have been. You could have made a solid there. But they didn't. That's a 2 and a 2 there. Okay, again, no. Double replacements are not redox. This is an acid-base neutralization. When you add an acid plus a base, you make water plus salt. That's the definition of a neutralization, basically. Okay, sulfuric acid, H2SO4 plus KOH. All right, plus 1, minus 2, plus 1, minus 1. So that means the minus 2 sulfate's going with the plus 1 potassium. So I'm going to get a salt, potassium sulfate. All group 1 salts are soluble without exceptions, plus water. Okay, acid plus a base is a neutralization. It makes salt and water. And no, it is not a redox. Thanks so much.